Hello guys, welcome back to the channel. Welcome back to Math Plus Tech. In today's video, I'm just basically going to tell you about the limit of single variable functions. We first consider the limit of single variable functions, what they are and how we should consider them. In another video, I'll talk about that of multivariable functions. Let's take the basics first before we go forward. Yeah. Now, to start off, the simple question is, what is limit? What do we mean by limit of a single variable function? When we talk of limit of a function, we are interested in what happens, the behavior of the function as its independent variable approaches a certain value. So if I have a function f defined on x, I want to know what happens to this function f, what kind of output this function produces as x approaches a certain value, let's say x naught. And this value would definitely be given because that is what we are studying. Now, let's draw a graph. Let's say this function f of x is plotted on a two-dimensional plane like this, where x is here. Then this represents the functional value, let's say y, given that maybe this is equal to y. So y is equal to f of x. Now, considering this graph, let's say x naught is here. We are interested in what happens as the value of x approaches this x naught, either from this direction or from this direction. What happens to the value of y? What happens to its value? So let's say at this point, let's say this value is here, and let's say at this point this value is here, and now you'd realize that as you approach it from this time, at this point, this value, the functional value f of x, also approaches a certain value around here. Now, is it the same thing that happens when you approach it from here? And this brings about the right hand limit and a left hand limit. Now, anytime we would like to find a limit of a certain function as x approaches a certain value, we write it in mathematics as the limit as x approaches a certain value x naught of the function f of x to be equal to L. So this becomes the limit as the function's independent variable, in this case x, approaches a certain value x naught. Now, I talked of the left hand limit or the left limit and the right hand limit or the right limit earlier. To represent that, we put a little plus and a little minus on the x naught here. So if I want to talk about the left limit, which is basically saying we are approaching the x naught from the left side, I'll write that as the limit as x approaches x naught from the left side. The negative here signifies that we are approaching it from the left side of f of x we equal to maybe L, just a little negative here to represent that we are approaching the value from the left side. We are approaching x naught from the left side. And then the right limit, we write it as the limit of f of x as x approaches x naught from the right side or from the positive side. And I can write that as something like this. Now, to say that a function has a limit, as x approaches a certain x naught, we must first know that the left hand limit should be equal to the right hand limit. Now I'm going to repeat that again. To say that a function has a limit, we must first establish that. Let me write that in red. We must first establish that the right hand limit is equal to the left hand limit. Essentially, we are saying that the limit of f of x as x approaches x naught from the right side should be equal to the limit of f of x as x approaches x naught from the left side, and then this value becomes the limit of the function f of x. Now we should know that if the left hand limit is not equal to the right hand limit, then the function does not have a limit as x approaches that value x naught. That's the concept. So either it has a limit as you approach that value, or it doesn't have a limit. And for it to have a limit as you approach that value, the left hand limit should be equal to the right hand limit. And also say that if we are talking of limits, we are not interested in what happens at the value that we are looking at the limit, but rather we are interested in what happens to the function as we approach that value x naught from all the sides, from all possible sides. Now, to make the concept a little bit clearer, let's consider the example. Let's consider the single variable function f of x to be equal to 2x. Now, what we want to do is to approach a certain value. So let's say we are finding the limit as x approaches 2. And we would write that in mathematics as the limit of f of x as x approaches 2. Or you can simply just write this as the limit of 2x as x approaches 2. Now, like I said, we are not interested in f of 2, but we are interested in what happens to the function f defined on x when we approach 2, both from the left side and from the right side. And then these limits, when we approach it from these two sides, should be equal. So let's start. The first thing to do is to approach 2 from left side. Now we know that the number line is something like this. So if 2 is here, approaching it from the left side would be coming from this side, which would mean numbers less than 2. And then approaching it from the right side would mean approaching it, taking numbers greater than 2 and decreasing them towards 2. So let's say we have the values of x and we want to know the function f of x. We want to know the value of the function f of x. So we take like 1.5. f of x would be 1.5 times 2, which is what? 3. Now if you take a value like 1.6, also we are kind of approaching from the left side, so we take it 1.5, 1.6. So we take this value, f of x would be what? 1.6 times 2, which is what? 3.2. If I take 1.9, I get 3.8, right? If I take a value like, let's say 1.95, I get a value 3.9. What if I take a value 1.99? This times 2 would give you 3.98. Now, as we approach 2 from the left side, from 1.5 to 1.6 to 1.9 to 1.95 to 1.99, getting as close as 1.99, we realize that the value of the function, let me change this color, the value of the function gets very close to a certain number. You can say 4. The value of this function starts from 3, goes to 3 points, goes to 3.9, 3.98, and gets close to 4, but it never gets to 4. So that's what happens to the function when we approach it from the left side. Now we would also consider the same thing. What happens to this function when we approach 2? So approaching 2 from the right side. So we start off with, let's say, 2.5. So if this is x and then this is f of x, start off with 2.5, right? So 2.5 times 2 will give us what? 5. So we reduce it, we go to 2.4, we get something like 4.8, right? And then we'll have 2.3, 4.6. Let's say we get a little closer, let's say 2.1. That will give us what? 4.2. Let's say we reduce it a little further, we have 2.05. That will give us 4.10. If you reduce it even further to something like 2.0005. That will give us what? 4.0010. Essentially, we are multiplying the value of x by 2. Since that's the definition of the function, we are multiplying the value of x by 2 to get the functional value, to get what happens to the function as we approach 2 from the right side and from the left side. And we realize that in this case too, as we approach 2 from the right side, from 2.5 down to 2.0005, we end up approaching a certain number. In this case, it looks as if we are approaching 4 again. As we decrease from 5, went to 4.8 up to 4.00010. So it's understandable that we won't get any lesser than that. So we can finally conclude that since the left hand limit, when we approach this from the left side, we had 4, and when we approach this from the right side, we had 4, we can finally conclude that 4 is the limit of f of x as x approaches 2. So this becomes 4. The limit of f of x as x approaches 2 becomes 4. Now, certain functions, it is easy to get. For this particular one, realize that the limit of f of x as x approaches 2 is just the functional value, f of 2. And this is equal to f of 2. But it's not always the case that the functional value would be equal to the limit. And as such, care should be taken when considering limits. And yeah, that's it for this video. That's basically it for this video. I would like to ask you all, ask you to really go and read about limits, because they are very important in calculus. They are one of the fundamental concepts that you would need. Like, it is a required concept when we talk about calculus. And as such, you should go and read about it, learn more about it, and yeah, I'll see you in the next one. That's it for this video. If you enjoy, please leave a like behind. As usual, if you are new around here, feel free, subscribe if you are new around here. And yeah, I'll see you guys in the next one.